Welcome to Carlton's Math Corner. Today, we're going to continue our study on real numbers. First of all, of course, start off by having your math journal out, have something to write with, as well as your vocabulary packet. Our target today is I can determine if square roots are rational or irrational. So, here are two examples of a couple square roots. We have negative square root of 22 and then negative square root of 64. Can you explain why these are, why this one is irrational and why this square root is rational? Well, you're absolutely right. Negative square root of 22. If I put that in the calculator, I get negative 4.690415, etc., etc., etc. Notice there's no pattern, absolutely none, and it continues infinitely. So this is an example of an irrational number. Over on this side, negative square root of 64, I know that 8 times 8 is 64. And if I am focusing on the negative, negative 8 times negative 8 is 64. So negative 8 I know is an integer. It fits in the category of a whole number and its opposite, and I know that that is an example of a rational number. So that fits in the category of a rational number. Now, another reason why this doesn't fit as a rational number is the fact that I can't write this as a fraction, and that is the definition of a rational number. There's really no fraction that would get me exactly this number, this decimal. I could maybe find a fraction that gets me close to it, but not exactly this number. So let's kind of review what a rational number is and an irrational number. So a rational number, remember, are numbers that can be written as a fraction. And so here are all the examples of rational numbers, the different types of rational numbers. Whole numbers, fractions, decimals, integers, natural numbers, mixed numbers, square roots, percents, and powers. Irrational numbers, really just any number that turns into a decimal and the decimal goes on infinitely with no pattern, and you really can't predict what's coming next. So irrational numbers can't predict what's coming next. Rational numbers, you can predict what is the next number. So if we look at some examples, let's put these in the two categories. So positive 7. Which category would you put this in? Rational or irrational? Yes, I too would put this in the rational category because I can actually take 7 and I can make it a fraction just by putting it over 1. 7 divided by 1 is still 7. So I just made it a fraction, and so it fits in that category. It is considered a whole number, which is an example of a rational number. How about 345 thousandths? Where would you put this? I too would put it in the rational category because actually the way it is said in words, 345 thousandths is actually the way that you would write it as a fraction. It's not in simplest form, but that's one way to write it as a fraction. And so it is considered a rational number. How about square root of 11? And you may need to take a calculator and see what is the square root of 11. Well, when I put it in the calculator, this is what I get. 3.31666247, blah, it just keeps going on and on and on. Which category would you put this in? Yep, I too would put it in the irrational category because this is one of those examples where the decimal continues. It goes on infinitely and there's no pattern. I wouldn't even be able to tell you what comes next. How about the next one? This decimal also would be in the irrational category for the same reasons. There's no pattern, can't predict what comes next. How about the square root of 4? Well, I know that 2 times 2 is 4, so I would get a whole number of 2. So actually, that is a perfect square root because I get a whole number. And I know whole numbers are in the category of rational numbers, so I would put this square root of 4, I would put it in the rational category. How about a mixed number, 2 and 7/8? Well, do you notice it's already written in fraction form? It already has a fraction in it. So technically, this is 2.875 because 7 divided by 8 is 0.875, and then there's 2 wholes. So this is a decimal that terminates, so that puts it in the category of as a rational number. How about -10? Yes, rational number because it is an integer. And so we'll put that also in that category. And then lastly, 3/5. Yes, 3/5 would go in the rational category because, well, it's already a fraction. And the definition of a rational number is any number that can be written as a fraction. So it fits in that category. For tomorrow, what I would like you to do is I would like you to complete the following 4 problems. Please determine whether each number is rational or irrational. And I would like for you to explain why. Maybe within your explanation, you classify the numbers, with additional names, but give an explanation of why you picked that category. Okay, thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.